tylko na Ekspert. Druk 3D Metali, medycyna, Pola, Walki. Jak się okazuje, o czym dowiedziałem się na konferencji na temat praktycznych zastosowań druku 3D w przemyśle i w badaniach, w której uczestniczyłem ostatnio we Wrocławiu, że właśnie druki 3D, w ogóle trójwymiarowy design, czyli projektowanie modeli 3D, wykonywanie ich potem z wydruku metali różnego rodzaju, specjalnie przystosowanych do implantów, po prostu wspiera ukraińską armię w odzyskiwaniu potencjału bojowego. Dzięki specjalnie konstruowanym implantom można szybciej i w pełny sposób odzyskiwać zdrowie. Miałem okazję zobaczyć bardzo ciekawą prezentację. Przy okazji ją nagrałem i tutaj w dalszej części filmu ją odtwarzam, żebyście mogli zobaczyć. Ta prezentacja była właśnie na temat tego, jak jedna z ukraińskich firm typowo stricte technologicznych wspiera właśnie tą gałąź medycyny specjalnie projektowanymi już pod konkretnego klienta, pod konkretnego poszkodowanego wydrukami 3D. Właśnie w technologii druków metali. Tutaj w górnym prawym rogu możecie zobaczyć taki filmik, który też opisuje pewną specyficzną sytuację, gdzie twórca technologii sam po tym, jako poszkodowany z niej skorzystał właśnie w trakcie konfliktu na Ukrainie. Zapraszam do odsłuchania prezentacji.
And first of all, I would like to say thank you for the organizers for inviting me to give this presentation. It's a pleasure for me to present here today. So first of all, I would like to start maybe from a little bit from the background and why you would be interested to listen what's going on later on these slides. So I'm the CEO of Sweden Metal Tech Company. This is a small high-tech company in Ukraine which is focused on metal additive manufacturing for medical and veterinary applications. Right now, for the moment, we are the only one certified manufacturer in Ukraine who specialized in 3D printing of customized patient-specific implants. And since we were established in 2020, the company already produced more than 500 patient-specific implants, and more of 80 of them was for war victims. Probably all of you are familiar with general advantages of additive manufacturing, and basically in medical field these general advantages are pretty similar. So it's why additive manufacturing is important in medical application. Basically, it's possibility to produce complex geometries. It's possibility to make lightweight constructions and trabecular structures. Good example you can see on this picture, because these trabecular structures are improving bone ingrowth and secondary stability of the implant. It also allows to make surgical planning and surgical trainings, and it's a possibility to produce patient-specific solutions for complicated cases or for revision operations, revision surgeries. So how it usually works with planning and training, it allows the surgeon or let's say bioengineer to create an anatomic model and make a virtual plan of the operation on the screen or select the correct anatomic angles, etc. For example, this is a real case. This is for veterinary medicine. This is a dog, if I remember correctly. And basically, after the bone has some defect, and it should be corrected by osteotomy, and proper surgical guide can be created based on the pre-operational planning for the correct anatomical angles. And after that, patient-specific implants as a plate, you can see here, can be applied. And all of that can be done by, in virtual environment, agree with the surgeon, and basically it can reduce a lot the operation time, the surgery time, and it is also a very important thing. The one more thing about training, actually, it can be also done in plastic. So the surgeon can use a plastic bone model and train to cut it and perform so-called operation before operation. Or it can be used by students, medical students, to train how to perform such type of the surgeries. And patient-specific implants has plenty of advantages. For example, why they are better than standard solutions for a certain case, because they have perfect fit. They are produced and modeled, designed for a certain patient and certain defect for a certain autonomy. So they have this perfect fit. Also, they reduce the surgery time and for potential complications because they are using special guides and navigators. And in the end of the day, as I already told, they can be applied for extra complicated cases or revision operations, as well as they can be applied for plastic surgery, for example, to make your face look natural after some defects, etc. Which is not possible sometimes not possible to achieve with standard solutions. And also in some cases, PSI can help to save limb from the amputation. How the general process looks like? First of all, we have a CT scan, then from CT scan we create a 3D model of bone with a defect. After, based on this model, the implant, the 3D model of implant is designed, and then it can be printed in titanium. And at some stage, as I already told, plastic model can be created, and surgeon can try it in real size and maybe give some feedback or make some changes to the final implant design. Right now we move to the most interesting, I would say, and most frightening part of the presentation. It's real case examples. Also, I would like to mention our partners. It's Ukrainian and international companies. For example, I believe all of you know the company Materialize. It's very famous in additive manufacturing community. So first case which I would like to share with you is a victim. Patient is a civilian. She got injury during the Shepard Kramatorsk railway station in the beginning of April, which she was trying to evacuate a lot of civilians were at that railway station that day because they were waiting for evacuation train and missile. It was a lot of victims and a lot of injured people. She was one of them, and her condition was pretty bad. And as I told, it happened in April, and on the first bone reconstruction happened already in July 2027. So it's like 4 or 5 months of pre-operation time during this time she had a lot of surgeries, like maybe 9 or 7 or something like that, like some vascular surgeries, etc., etc. And the first stage of the bone reconstruction, it was a face reconstruction. It was 4-component patient-specific implants, which we produced in cooperation with Materialize. They have some volunteer team which helps in terms of patient-specific implants here in Ukraine. But the operation was performed in July. However, as you can see from the picture in the right corner, some mandibular part are still missing, and this was the second stage of the reconstruction, and we did it in cooperation with Ukrainian company Imatech Medical. And this stage was done in October, so after the total recovery of the patient after the first stage of the reconstruction. One more example is patient-specific hip joint. So basically, the patient, he's a soldier and he got a gunshot injury in a hip joint, and the joint was replaced with a total hip implant, and one component, several cut of the hip implant was patient-specific in this case, and you can see the post-op X-ray image here. This case was done in cooperation with Wspomnienia and Dr. Haluzinski. Let's move to the next case. I would say it's the most interesting case because this guy you can see here, his name is Alexander, and he's not like soldier, professional soldier. He used to work in IT industry as an analyst in a company which you probably know, it's Materialize, and he used to develop medical software for craniomaxillofacial applications. He was one of the guys who were developing this software, and when the war started, he was called by a military office and he went for a war and got injured. And the irony maybe of this case is that he got treated with the software, with the application of the software which he used to develop before. This is his implant, how it looked like. It is not visible here, but basically this jaw is, it has a defect, and there are 2 fragments. Basically, on the model it looks like it's only defect, but basically this fragment is separate. So the blade, this implant, it fixes the jaw in the correct position, and basically it fixes 2 fragments together with the possibility to put inside some bone material. However, for example, Ukrainian governmental program does not cover the cost of these implants yet. So we as a company decided to define our position as that for the patient who is a war victim, it should be for free definitely, and we are trying to find some fundings ourselves from charity organization by contacting them, etc. Or if we cannot, then we do it by our own. Let's say we are covering the cost. So we defined this position in the beginning last year when we returned to Kyiv and started our production again, and till now it still works like that. From the production side, basically, when the war started, it was the first war for all of us, let's say, such, and we find some eradication issues, which, because in the beginning nothing was understandable, and when in the first days we left Kyiv, almost all of my colleagues we left the city, and after 2-3 weeks we returned back to pick up the the equipment and try to relocate the production to a safe place, or at least to be able to start this production somewhere in a safer place. However, yeah, it was an interesting experience, but yeah, let's not stop on it too much. But later on we returned when the key region was occupied and started our production in the same place. Later on we got some infrastructural problems with electricity supply, etc. And for example, why I decided to show this picture, because all of you probably know that such high parts, it's usually printing time is quite long, and it's the fact this platform was printed, it's actually a pure luck, because that time we didn't have a diesel generator, and electricity supply was available for example 6-7 hours, and then for 3-4 hours it was cut off. And this printing job was printed for more than 24 hours, and the fact that it was even printed, it's a pure luck.
I have questions to Yaroslav.
Hi, great presentation. Thank you very much for this. I've got quite pretty much informative question in terms of, I observed many lattices that are being applied to the implants. What is their importance, and actually do you have any criteria where you select the lattice to the individual application?
Thank you very much for your questions. Yes, as lattices are one of the main, let's say, idea of additive manufacturing, especially. There is two main criteria why they are used. If we are talking about, for example, a stapler cups for hip joints, there is a specific volume lattice with pore size about 0.8 to 1 millimeter, and based on the previous experience, based on some publications, it was defined as such pore size for lattices is the best for bone ingrowth, and basically this implant can achieve secondary stability. So first it fixes with screws, and then bone is growing inside the lattice, and it becomes more stable. And I saw such, in 2 months it's already quite, the result is quite good. However, for example, if you are talking about cranial maxillofacial implants, there is, it's not like volume lattice, it's just a plain structure just to make the implant lighter. So it's more about weight. There is no need for, there is different bones, let's say, and there is different type of lattices. For example, if we are talking about cranial maxillofacial, it's more about weight. If you are talking about other bones, it's also for improving the surgical, clinical performance as well.
Thank you. Is someone have any questions? Okay. Thank you very much to connect with us. We are thank you once again.
Jak się okazuje, Ukraina po tym konflikcie będzie miała nie tylko bardzo dobrze przeszkolonych i doświadczonych żołnierzy, ale również bardzo wielu bardzo doświadczonych chirurgów i innych specjalistów, którzy mają unikatowe doświadczenia właśnie w leczeniu ludzi po różnego rodzaju urazach i zranieniach wywołanych konfliktem. Co z całą pewnością będzie bardzo korzystne globalnie, kiedy ci lekarze i ci specjaliści zaczną się dzielić swoją wiedzą, ponieważ tego typu urazy zdarzają się również w różnego rodzaju wypadkach komunikacyjnych i ta wiedza jest bezcenna. Dziękuję Wam wszystkim za uwagę i zapraszam na kolejne wspomnienia konstruktora.